International Airport, Baltimore, Washington, Maryland. December 8, 2005. On the tarmac, a Southwest Airlines Boeing 737-7H4, destined for Las Vegas with layovers in Chicago and Salt Lake City as part of Flight 1248, is preparing to depart. A total of 103 people board the plane, 98 passengers and 5 crew members. The experienced crew consists of Captain in Command, 59-year-old Bruce Sutherland, First Officer, 34-year-old Stephen Oliver. Additionally, 3 flight attendants are working in the cabin. Due to heavy snowfall and adverse weather conditions in Chicago, Midway Airport is closed to incoming flights. The air traffic controller informs the crew of a 2-hour delay. After weather conditions improve in Chicago, at 5:58 p.m. local time, the crew receives clearance for takeoff. The Boeing 737 takes off from Baltimore Airport en route to Chicago. After 30 minutes of flight, the aircraft approaches Chicago Midway Airport at an altitude of 10,000 feet, or 3,000 meters. At this time, the controller instructs the pilots to enter a holding pattern due to heavy snow removal equipment operating on the runway. At 6:44:04 p.m., the crew reports entering the holding pattern. Simultaneously, they receive updated weather information from Midway Airport, including a wind direction of 090 DOD at a speed of 5.6 ms. The crew enters these data into the onboard computer to calculate the required distance for a normal landing on runway 31C. Based on the entered data, the computer calculates a tailwind component of 4 ms. According to the airline's rules, landings are permitted on any runway with a tailwind speed up to 5 ms. However, landing is prohibited with a tailwind exceeding 2.5 ms when the braking efficiency is low. The pilots are aware of these rules and understand that, with low braking efficiency, they might roll beyond the runway during landing at Midway, as the onboard computer is not programmed to provide results for mixed braking. The first officer inputs various scenarios, including low and normal braking efficiency. For the first case, the computer estimates that the aircraft should stop 12 meters before the end of the runway, and for the second case, it should stop 170 meters before the end. Additionally, the crew decides that if the tailwind component exceeds 5 ms, or they receive reports of low braking efficiency along the entire length of the runway, they will divert to the alternating airports, Kansas City or St. Louis, both located in Missouri. The crew also receives a message from the Automatic Terminal Information Service (ATIS) system, indicating that the visibility on runway 31 average was approximately 1,500 meters. 10 minutes after entering the holding pattern, the controller provides our crew with a radar vector and instructions for descent, and Flight 1248 begins the final approach to align with the localizer for runway 31 center. At the same time, the crew receives information about the visibility on the runway, fluctuating between 1,400 meters and 1,500 meters, while the ATIS system reports a wind from 100 degrees at a speed of 5.6 ms. This exceeds the company's policy minimums. The correct decision would have been to divert to the alternate airport. However, the crew continues the flight and prepares for landing. At 19:03:44, the controller grants permission to proceed to the glide slope of runway 31C, and less than a minute later, conveys that the braking efficiency on the runway is normal, except for being low at the end. 9 minutes later, the second pilot receives clearance to land, and the Boeing 737, at a speed of 230 km/h, touches down firmly on runway 31C. The pilots align the aircraft with the runway's centerline and begin using the brakes. However, the captain forgets about reverse thrust. At that moment, the pilots feel the anti-skid system engaging, unlocking the brakes, and the aircraft seems to accelerate. The second pilot, realizing this, shouts that they need to brake urgently. Forgetting about reverse thrust, the captain, along with the second pilot, manually activates the wheel brakes. Then, looking at the throttle panel, the second pilot sees that reverse thrust is still not engaged. So, 15 seconds after touchdown, the crew finally activates the reverse thrust, which fully deploys after another 3 seconds. Essentially, reverse thrust only began to work 18 seconds after touchdown. Despite all the crew's actions, the airliner does not stop and continues down the runway. The Boeing 737 travels the entire length of the runway, overshooting the end, crossing the entire safety area, striking a navigational aid antenna and a blast fence. It crosses the road perpendicular to the airport, hitting a fire hydrant and a northbound car, only coming to a stop at an intersection 150 meters northwest of the airport. After stopping, the second pilot began to read out the checklist for evacuation, while the captain went to the cabin to check on the passengers. Subsequently, all individuals on board evacuated through the front left and rear right doors. Within a couple of minutes, the first emergency services arrived at the aircraft. The aircraft sustained damage to the leading edge of the wing and engine nacelles, but the cabin and cockpit were unaffected. It was later restored. Out of the 103 individuals on board, 18 suffered minor injuries, 1 flight attendant, and 17 passengers, while the remaining 85 were relatively unharmed. However, out of the 5 people in the struck vehicle, 1, a 6-year-old child, died. Trapped, the child suffocated in the twisted metal. Another person sustained serious injuries. The aircraft also collided with another vehicle, but the occupants were relatively unharmed. The investigation of the incident was carried out by the National Transportation Safety Board, NTSB. In its final report, the NTSB Commission concluded that the cause of the incident was a pilot error. The pilots applied reverse thrust too late to slow down to a safe speed or stop, resulting in the aircraft running out of runway. The pilot's mistake was attributed to their lack of experience with the automatic braking system and insufficient knowledge of its operation, leading to a distraction from applying reverse thrust during a challenging landing. Southwest Airlines also played a role in creating the situation. The airline did not provide clear and consistent guidance and training to its pilots regarding adopted procedures and company policy related to distance calculations for landings. The programs and design of the onboard computer did not incorporate built-in assumptions critical for pilots' decision-making. The company planned to implement a new automatic braking procedure without a familiarization period. The landing distance assessment did not include a safety margin that would account for operational discrepancies. The crew's reluctance to divert to an alternate airport after receiving a report of low braking effectiveness with a tailwind of more than 2.5 ms also contributed to the creation of the emergency situation. Additionally, the incident could have been prevented if the runway end safety area of runway 31 Center was equipped with an emergency braking system, which could have stopped the aircraft that had overrun the runway in that situation. After the incident, the aircraft was restored but re-registered, resulting in a change of its registration number from N471WN to N286WN. As of today, it continues to be in operation with Southwest Airlines. Although the event involving Flight 1248 is classified as an aviation incident rather than an aviation accident, the airline took customary actions such as changing the flight number. The runway 13C-31C at Midway Airport was equipped with runway end safety areas. Over its more than 30-year history, this incident marked the first for Southwest Airlines that resulted in human casualties.